Okay, we're here, and hopefully the sound's better than the last video. I had the mic set on an omnidirectional thing, and so it was grabbing all the sound around, and I was just trying to keep the noise quiet with the air conditioner going, so it was a bit low level on the sound. But now I've changed it back to the original settings. I'm looking at the level, it looks pretty good. And today we're going to talk about second row face design. That's right. So just thought I'd continue on the tack that I've been doing from the last video, and start talking about how you would go about doing your second row design after you've done your face row design. And the idea is that it'll be kind of like talking about quarrying shots, and in open cut you don't probably need to worry about this as much depending on your location of your mine, but as I said, each mine site's different, so you can't just tar every mine site with the same brush. Certainly you can't. So anyway, let's jump straight into it, and I will get the picture up. We're back in Paradigm again. Quite enjoying this program at the moment. Like the learning curve's going pretty well. So seems to have a lot of good features. And so anyway, so we left off with this blast. Now this was the this blast that we're looking at is the blast where we use the baseline method. So that's the face row with the baseline method, and then turning off those baselines and turning on this line here. We can see this is the second version that we did, and I mean I really don't like the ugliness down here, and I measured the separation between these two toes. It's about 7 meters, which was a bit alarming for me, but you might want to, I mean, we could probably turn that and push it back a little, so sort of like curve it around, but it might just end up needing to be brought forward, because as we turn it away, we're going to be turning it away from the face. Anyway, so we're going to leave the designs as we did, and you can see there's considerable difference between the two designs, especially on the second face, where you can see the holes are much closer to the face there and steeper, and we even though they're on the same line, so I made some different choices between there. And as you can see, this is where it comes down to saying there's no right or wrong with the design. It's your choices at the moment, as long as you made reasonable choices, and those reasonable choices are noted, I guess. I'm hoping I designed this second face and I didn't just bail from the mission. Well, we'll find out anyway, won't we, if I messed up. Let's just check that very quickly, and I'll find my correct tool. Still learning my way around it. Whole X section. Well, it looks like I didn't do these designs, which is a bit sad for me. Here I was thinking I was prepared for this stream, and I'm not. So let's leave that, because those won't take too long to do, and I will come back to that when we jump into the next method, because the first method is about this stream is about the second row design. So we're going to ignore the second blast at the moment, and we'll come back to that. But what I wanted to talk about, I don't know why this pops up all the time. Anyway. What I wanted to talk about here is a couple of tools to use. So let's look at a couple of tools to use to generate what you would do on your second row. And I've got a few. Now there's one you can use in the field. So this method of baselining was what we did in the field. So it was sort of like we set up our baseline scans, like I mentioned. We'd set up that line, and we'd scanned it from out here, and then we had done chainage and then offset off the baseline. So that was the method that we used there. That's pretty, and I do like this method because it's you're thinking about things in the real world, and this is always the case. Always the best method to do things is think about things in the real world. What is going to happen? So so we had that baseline. Now if we were in the field, we might use a little guide. What's going on here? Don't know why that's popping up. Stupid Windows stuff. Anyway, let's move to the Excel sheets that I prepared earlier. So we're sort of, this is a cross-sectional view of our blast that we're probably going to try to achieve. So it's kind of a 3.6 spacing with a 3 meter burden, and we got a 12-degree quarry face, and we've got our first row is at 12 degrees, our mast angle 12 degrees, or dip would be the 90 minus 12, which is the 78 degrees. So if you speak in dips, then 78 degrees. And our second row, we're going to stand up to 5 degrees, and then we're going to aim to go back to vertical blast holes. Now, you might keep all your blast holes at 5 because it's more convenient. You might keep them all at 10, then it's even easier. But what we're going to do is we look at this separation here, and we can see that I've drawn this up as needing a 1.4 burden off a 12 meter bench with 1 meter of sub drill. I'm looking at 12 degrees, and the next one to get 5, I need a separation there, a 1.4 separation, so it's that way inclined. So if I jump on there and I were to type in 2, that should push it out, and that will take it to 3.6 meters of toe separation over here, and that's too much. That's overburdened at the toe. It looks nicer at the top with a kind of like 2.7 meter separation in the charges at the top, but 3.6 is too much burden at the toe, so we would not be doing that. We're going for 1.5, let's say. What did I say, 1.5? Oh, it's 3.1, so it's 1.4. So setting at 1.4 behind a 12 degree hole, and because we're going to do a staggered blast, so we've got the 2 holes there, and then this next one's going to be in the middle. So we need to think about this hole at 12 and this hole at, well, it might be at 17. So then we need to split the difference between those two and think about it. Now, this is a bit more of a complex tool to use if you're in the field, but if you are not in the field and you're just going off, you'd be using this kind of separation chart here, where you've got a 13 meter bench and you've got a 5 meter, so this is a vertical depth versus length, so I haven't brought up the right chart. Apologize for that. The chart that we spoke about last time, I'll bring that up in a little bit, and we'll try to find that. That one, I'll try to find that. So a chart like this is just angle and the overall length of the hole, but the one that we talked about, whereas there was the tangent separation, those are the things you want to try to match. So that's what we're matching on this one here. That's what we're matching. This is sort of like the tangent length, and you can see here that 1.4, so we're looking at that. This length is pretty not quite right. I must be calculating the bench to charge. Anyway, let's ignore this column for the moment. It doesn't seem to be reporting the right value. Anyway, but this is the what we're looking at. We've got 1, 2, 3 meters of separation between toes, which is our burden. That's what we're aiming for. So let's move back into this, and so we're looking at a 3 meter toe separation there. So there's a couple of ways you could do this, and in the field, is to understand what this crest to toe separation is. So the crest to toe separation between the two values. So whilst we're looking at, let me just go quickly pull up this other spreadsheet. So I'm going to take a little break, and we'll pull up the spreadsheet and make sure that it's working. Okay, I'm back, and I've got it. Took a little bit of time to find it because I'm fairly inept at working my way through the computer. Anyway, so we're looking for that 13 meter toe, or that length of the bench, let's say at 13 meters deep, or we can even look at the 12 if we want to compare apples for apples, and so we're at a 12 degree, so 2.5 from collar to toe, that's where the toe is, so 2.5. So then if you got 3 meters, you want to take off. So if it was vertical, you would put your blast hole half a meter behind, right? Pretty easy if you're thinking about that. So let's say we got 2.55 there for our 12 degree hole. And we've got change this degrees here to, let's say our next hole behind is going to be 5 degrees. So our collar to toe separation is 1 meter. So it's 1 meter forward. So wherever the collar is, it's 1 meter, about 1.5 meter, 1.05 meters or 1.1 meters forward of the collar location. So what does that mean? Well, we need to get 3 meters. So we got the hole is forward 1.5 and our toe is forward 2.5 from the other location. So kind of need to work out what that is at. So this is 5 degrees. So these are the differences between the collar and toe separation. So let's just go back to our little example here, and essentially what we're talking about is at these points here, this is 2.5 meters forward of this location. This is a 1 meter forward of this location, and so our difference is this 1.4. So anyway, quite a convoluted sort of conversation. So if you were to look at these values here and take if we were just to take I'm trying to find this and minus this off it, we're looking at the collar separation roughly of what we need. So 1.4 meters. So if these were actually, let's change those down to these value. Anyway, so we're sort of looking at about 1.5 meters behind. So pretty easy, we just need to calculate. So you'd use this sort of value, you'd write down your offsets and go for it. But we're not going to do that level of detail, we're not going to do that right now because it'll take too long for us to prepare that file. What we'll do is we'll do it in the computer. So that's one way of doing it, which is saying, well, this is 12 degrees. Let's just check that. 12 degrees. And so if we were to put a hole directly behind that and ensure that it had a 3 meter separation, our hole would be only 1.4 meters behind it. So if we were to put it directly behind, it would be considered a helper or a lifter. This one is going to go across here. But because this is greater, this value here is greater, this one is a 16 degree hole. When we are thinking about that value, so let's just wind this back so I've got some more space on the screen. So if we're thinking about we've got 1.5 behind, and we've got sort of like, what did we say, a 16-degree hole. So let's change this to a 16-degree hole. So our 16-degree hole is 3.4, so we don't have much value. So to get a 5 back to 16 is going to be really, really difficult to do. So we're going to have to overburden the second row if we want to maintain that row to 5, or we would increase the angle and say, well, we can't do a 5-degree and ensure our toe. We might have to do a 10-degree and ensure our toe. These are all decisions you make in the field. The next row of holes would have a little wobble in it. So now you'd take your aligning row, your third row back, would be even also slightly wobbly until you get to your fourth row, and then that would be your straight row in the burden. But you make all these decisions in the field on the fly, and you just have to make them the best way you can with this method. I hope I'm being clear and understanding. So that is how you would work it. You'd find out that that's the difference of 1. So that would be like with a you'd find that quite hard to do. It's actually, to put a 5-degree hole in here at 3.4, it's half a meter forward of this location. So it sort of like defeats the point if you've got a point like a half meter forward and a 1.4 behind. Yeah, it doesn't really work out. So the best thing you can do is sorry, that would be half a meter. Yeah, that's correct. The best thing I think I can do in this occasion is we're just going to, what I did before was digitize the toe line of these blast holes. Let's find that. Blast one, toe of holes. There you go. So I've digitized this this toe line over here of all the blast holes, and let's just turn the blast surface off so you can see that in 3D. Oh, it's a bit high, so let's select that line, drop it down to -1, right, which is on the toe. Okay, there you go. So we've got this line that follows as best we can the toe line of those blast holes, as you can see there. Moving on. So what I'm going to do is in this method offset it, just for cheat's sake. So you do this with the other method. So this one method we can do. So this is in the computer, but what I want to do is get that clear, that there's in the field work that you need to calculate through, and then there's CAD assisted sort of work that you do in the office, which is obviously easier, so it gives you more time to think and vet that sort of information. So we can get that in the plan view. We'll fit all the holes, and so I'm going to take this and we're going to offset this blast hole, or this row. I'm going to offset the line, not that way, and delete that. We're going to select it again and offset, reverse the offset, and we're going to, what did we say we were going to do? We did a 3 meter, so I have to change that. Select that line, and yep, custom at 3 meters. This is really annoying. Okay. And so now here we have our second row ideal placements. This is for the ideal placement of blast holes if they were vertical, right? Now if they're half a meter, well, if they're 5 degrees, then we know what that one's going to be. So this is like a, let's relabel this. This is blast 1 toe offset, but we'll call this blast 1 at blast 1, yeah, toe of second row, yeah. Right, toe of second row. So this is where we want to hit the target. We want the holes there hit this second row line. Now, you may not be doing second row holes on this side face. You may be incorporating rows that run out and they all aim this way. So this may not be something that you want to do, but you certainly want to know where the toe should be, so that if you can slightly adjust a second, like a normal burdened row hole, you can adjust that. But anyway, we're going to hit this line for our second row hole placement. Now, we know that 5 degrees has a 1 meter offset from collar to toe. As we looked at that, it's 1.1. So we're going to offset our blast holes 1.1. So let's just change that to double check it. 5 degrees, we're going to stand up at 5 degrees. So we're going to offset 1.1, because, I mean, 50 centimeters is a bit too tight. So we're going to offset this again. So let's select that one, and we will select that line, which I had before, but I let it go. I'm going to custom that, and we'll put 1.1. So this is where our blast holes are going to need to be for this line. The only thing I think I will do is I'll extend this line out on the end of it. But so this is where the collar position of these holes are, and you can see here it's going to be very tight. So there may need to be some charge alterations in order to make this fit correctly. And round this corner, well, it's not a big deal. Yeah, it's quite wide. So, but on this steeper face, we've got some quite close holes in here. So we can measure those distances in a second. But first of all, let me just edit this line, and I'm going to draw a line through there, actually. Just doing it easy. Rightio, I just didn't want to worry. I wanted this to be able to be fully in the center. So let's add holes along that line, shall we? We've got that. Yeah, so this is actually collar position, right? So this is now blast 1, collar position. You think by my age now I could spell correctly. Collar position. Uh-oh, what did I do there? Oh, I turned it off. There you go, collar position. Radio. And I am going to lift this for the sake of this, so that I don't have to, and then we'll snap the holes to the surface just to make sure. So I'm going to lift this to 12, I think it was 12, I'll just go 12 point, there you go, 12. So let's check that in 3D. Yep, so we're up the top there. That's where we're at with our line up the top of the collar of the holes. Pretty easy. And then we're going to generate those holes along that line. I'm pretty sure everyone knows how to do this sort of stuff. So what did we say our spacing was? 3.6. We'll just pull that over the side. .6, and you can see here these holes. Now I really should have done a little bit more research in finding out what the offset should be. So I think we're going to remove this down to here so that I can force the lines. So I'm not going to create those at all. We're going to move this line down here. I am sure that someone will tell me, who's used this program a lot more, that that's not how you do it. And that was pretty silly, but I think we're gonna start the first hole in the middle there. I think that'll be good right there. Maybe I didn't need to extend it after all that. What a waste of time. Anyway, we're good. Right, let's go holes along that line. Still got to fix all this stuff. And so then we've got these offsets. But as you can see, when you turn around a corner, you lose and gain at 3.6. You get some compression, and then you get some moving along. So it's not exactly 3.6 in the middle. It's kind of annoying in that regard, isn't it? So you could design a pattern behind this actually, and then do your adjustments. But at this stage, we're just going to do this and see these bits where the hole lines up. Well, this is not ideal, so we would move that hole along and move these holes along and manually adjust those. I think in this case it will be easier. It's not a lot of holes to manually adjust, but we started off okay, and then we got terrible compression and distortion from the angles that we do these things here. So you can either have your holes 3.6 meters directly apart, but as soon as you angle that, you're going to be, now you have to draw a triangle. This is why I love triangles, because you have to draw a triangle in your mind. Now that is that hypotenuse length, and that hypotenuse length is now greater than the 3 meter spacing on a, directly out from that. So if it's pattern wise, you're going to gain spacing, effective spacing or whatever, between, or intra-row spacing, distance is going to be increased. Right, not much we can do about that except either block out a pattern and move it manually, or do this and then move it manually. So we're just going to do this for this occasion. All right, so we've generated those holes in there, and let's see what we got. We generated those holes. They're all selected. I think we'll change the color of them. We'll give them blue. I'll close this, and we're going to give them all a 5-degree inclination, because that was what we wanted. And you can see right here they are kissing this line, this toe line, which is exactly what we wanted. It's not too bad. And then the only thing we had decided on prior to that is, I'm going to select these holes here. This is 127. So let's make sure that it's the same. 127. Group 1. So let's just rename this so that I don't mess it up. We'll call this second row. Now, blast one. I really like in other programs like Vulkan, the find by color. So I always design by colors. So if I have a notable hole with a notable reason, like say my first row of holes and my second row of holes are going to be different, I color them a different color in that application. So like in Vulkan blasting design module, I give them a color, and then you can see there's a little F icon that you can pin to the panel, and you can find by color. I love find by color because people think in colors, and if you are using find by color, it makes it a lot easier. Or you can group them. There's lots of ways to. There's always many ways to do the same thing, and this all comes because people just have different ideas about how they like to think about things and different ways they like to do. And this is great. This is perfect. Diversity of thought is the only real diversity out there, and I think people forget that. So diversity of thought. But we are going to give all these second. I'm going to select all these holes below. Sorry, I'm going to select all the children in there. That way I'm only looking in that area. And 127, we said 127. Hit that angle. They're all at 127, and we can see this area now. Now we would have to go through there and adjust these holes across so that they were directly behind this. But as you can see, what we've got is still a wobble, but it's probably not as accentuated. It is in this bit, not as accentuated as we thought. But what we can do with these scenarios is, if we want to straighten this row up, we can increase the angle of this hole. Let's say we were to put it at 10. Now we know that we can add, well, let's go to our Excel sheet and say what our separation is at 10. Well, it's 2.1. So we can add another meter on, another meter of offset on. So let's go back to the other one. So you can add another meter. So you can move this hole back a meter. So let's do that. Exactly that. Placement editor, or what might be better to show that? Let's go with this this whole X. I really like the whole X. The whole X. There might be an easier way. I got a message the other day saying, you did that thing, but there's an easier way to do that. and it's good. It's good to appreciate that. So we're not really concerned about this faced angle. All we're concerned about is moving this hole back a meter. So just to put in 1 there, and we're going to backward adjust this. All right. So now we're backwarding adjusting that, if that's a word, backwarding. Still a little bit, needs a little bit more, doesn't it? Needs to be nudged a little bit more. So we'll go to the whole move tool, and we've got a meter, but well, we might as well split the difference between the blast holes there and move it straight away. So we're sort of looking at that now. Now, what I'm trying to communicate in this position is that if you increase the angle on this second row here, now you are making these blast holes more in a line. However, this has a consequence, is that the next row has to be closer if it's 5 degrees. So whatever you do in this scenario means that sooner or later in the bulk of the shot you're going to have to accommodate some overburdening of the toe and some underburdening of the toes, and you just have to decide on where that energy is stored. And this is the concept that a lot of engineers and a lot of people just don't understand about blasting, and this is why I want to talk about it. Think of yourselves and think of a drill and blast engineer as a energy management technician or an energy management engineer. What you're doing is turning off, let's say you're a plumber, you'd be turning off certain pipes to ensure that the water doesn't come bursting out in a certain direction and hurt people or make your job difficult. And this is the same thing. We have an energy source. That energy source is explosive energy, chemical energy, and we're going to use that chemical energy to turn it into mechanical movement of the rock interaction, and we need to manage that energy. That's the key here, managing that energy. So where do you want to put your energy? Do you do all your storing of different overburdened, underburdened blast holes? Do you do that out on the face and risk face bursts or fly rock or high vibration from, or a massive overpressure pulse from the rock moving too fast and pushing on that air, because that's what actually creates that overpressure pulse. It's that rock hits the air and pushes it out the way, and that creates that pulse and does it so quickly, obviously. So you can put it all at the face and risk that, or you can put it all in the body of the shot. So the further back when you're in quarrying or something like that, further back in the blast that you manage your energy, or overburden or underburden, the less chance you have of creating a hazard. Your face is going to do, irrespective of what we are thinking about here. Like when we look at these sorts of blast holes, as an example, let me turn that back on. As we look into these issues surrounding these blast holes, let's finish that move tool, and we go into here. When we're looking, turn on this so that we can get this these green dots showing up. So as we spoke about before, these green dots are going to find the shortest distance to the face, and as we select different holes, you'll see where that energy is trying to vent to, and this is a prime example. This end one over here is that the hole is there, but these are actually, where was it? This one, correct. Selected the wrong hole. So we go out here. We've got this hole facing this way, but its shortest distance is here. So this face is going to move out at whatever speed it moves out at, whatever jointing or conditions are in the geology, whatever bedding planes are there, whatever weaknesses are there, that's just going to do its own thing, and you got to accept that that's going to do its own thing. So how you mitigate that is by restricting your energy. Either you would pull your whole blast hole back, or those sorts of things. So if you knew that this rock will, if it's got jointing that runs that way and is naturally running that way back on that angle, and the blast hole is definitely going to vent out that way because you saw a crack in the face or something, then that's something you want to consider. Increase that burden, shift that blast hole. Don't intercept the jointing, don't intercept the hazard or the problem. So anyway, we were talking about, I've started talking about face holes again, and we were talking about second row holes. So I hate it on that side. Let's do our best to look at these situations. So this one here, where now this is obviously going to be overburdened because we're not even concerned, but even that is saying that the shortest burden's that way for that hole. So, but we're pretty happy with these because they're hitting the mark. So now all we have to do is make sure that we're what did I say? We're halfway between these. Yeah. So this 10 degree, I mean, I like the idea, but it's kind of like I'm not sure that that's something that you would want to do. Maybe you want to just put in your next 5 degree holes and then live with it. So you could do this, you could do your first row at fluctuation, your second row at 10, and then your third row at 5, and your fourth at 5 and 5. That might be a valid way to do it, is to put all these at 10, put them back a bit so that you get this nice collar separation, and deal with it that way. That might be easier, and then put your 5 degrees in. So let's do that on this example. That might be easier. So as you can see, some of these angles are quite high. Like, you know, to go from 16 to 5 means that you're going to have this big divot, but 16 to 10 is less of a problem. So if we select these blast holes, select all the children, and we do exactly that and put it out to 10, then we can see here that we need to move all these blast holes back to this toe line of where our burden is, and then that may actually work out better because we'll get a better separation from collar to toe. Because what we're seeing with our separation collar to toe, what we're seeing with our separation at the, at the stemming zone, is that these are quite a bit closer. It's only 2 meters apart at that point there, and this is on a 12-degree hole. So if we were to turn this hole into that extreme one, which is 16 degrees, and we were to get this 5-degree hole to line up correctly, because now this is now 4 meters burden, so we need to move it over one. So we're talking about 0.4 separation between those two holes. The hole, I mean, do you know how big a drill hole collar is? That's a good point to think about. I mean, your drill hole collar is, your cuttings and that. So as you're drilling one hole, the cuttings from that one hole lay out there, and let's say in this case it's 102, so we've got probably a cone of about 300 or 400 mil maybe of cuttings over a 12-meter bench. On a 20-meter bench, maybe it's bigger. And then you go in, so let's say the cuttings extend 400 mil out, and then you drill a second hole only 400 mil away from that blast hole. If it's directly behind, you're going to be filling up the first hole with your cuttings. So the more separation between the collars of the hole, but maintaining that toe burden at a proper distance where the energy is mostly at below the bench, is probably a better idea. So here we've got a 5, and we would have to be 0.4. So if we put that back to, well, let's say it's a 1 meter there, and we decide that we're going to do that at a 10. If I can see my keyboard, yep, 10. And we're at 2.5, so we need to add another half meter onto it. 1.5, and we're sitting at 3. I mean, it's red because I've got a setting of 3 meters, so it must be just below that. Must be 2.9. So let's go 1.6. So you're looking at a much better separation from 16 to 10. Needs a 1.6 meter area, and then if you stand up to vertical, it's going to be a problem. So we would do a 5 and then vertical. So you can see this fanning of the blast hole angles is probably a really good way, but it becomes very, very complex, very difficult to manage for a driller. I'm at 42 minutes and I haven't even finished this design. Okay, so let's say we're at 10. We're going to manually move these because it will just be quicker and move on. So we're just going to grab our move tool and well, actually, let's not move out. You grab our move tool. We're going to move all these back 1 meter, but we're going to do it with the whole X. Design, nudging stuff. I'm not going to even look at that. I'm just going to nudge it back 1 meter, backward. Just to start with, just going to go through here, nudge it back. And it's not too bad. Let's zoom in on that and see where we're at. We're 100 mil forward, so let's say it's 1.1 meters. There you go. On you go. Backward. All right. That's not too bad. 0.1 backward. Looks like it's 1.2. Yeah, 1.2. Okay, right. So this is, we're just sort of like lining up. I do like this program though. This whole X thing is really good. I really like it. And we can move them across in a little bit. Yeah. So what did we say? We said 1.2. So I'm just going backward, and then we'll change this to 1.2. I really hope these are adding value to people or giving them some kind of alternate methods to figure out how to do their job. I do want to point out that if you like these videos, then you need to subscribe, or you don't need to do anything. Don't ever let anyone tell you what you need to do. But it would be really good if you were able to subscribe and like the YouTube channel and share it with other people who are engineers. That would be really excellent for me and help me out quite a bit. So I would love that if people would like, share and subscribe to me, so I could get the channel monetized and I could keep making these videos for you. Okay, so we've done that, and I didn't touch these ones because I think we're not going to use these. Let's get rid of these holes here. Yeah, I'm going to delete them because I think this is going to be our blast hole length, and so this one here I think I'm going to change to 5 degrees and move it forward. I think we'll move it forward. Yeah, and I'll just do this by hand for the moment. What is happening here? Got a problem. There you go, didn't grab it right. Because I like the idea that that would sort of sit in there, be very very straight rows, so we're going to do that there. I mean, kind of worried about this distance, but anyway, we've done this, sort of moved that along, and now we've nudged those back, so some of the work's done, but we might just shuffle these around a little. You know, maybe I should have just done that in the first place, just shuffle them around, but we just want them to be a very standard staggered pattern, and all we're doing here is lining up our toes so that we can not have very, I mean, obviously one of the best things you can do is draw. If you're doing moving blast holes by hand, you probably need to think about drawing in some guidelines for you, and drawing a straight line and then some perpendicular lines or some gridded action. So put in a grid and say this is where you would ideally like your blast hole to be. I like gridding, and I do like other tools, like other CAD programs. Like I really like Vulkan because you can snap to a lot of things, and there's a lot of CAD-like features on it that are good for blast design. But this doesn't take too long for a small shot, and these are all considered. So we're considering this is our line, and it looks pretty straight. It's getting pretty straight. So if we were to draw a line between those two scenarios, if we were to draw a line between these sort of like holes, and that would be our orientation of our blast, generally speaking. Or even better, we would have one, if we're thinking about this 127, you know, let's create a line. And we're sort of like, that's our rows are going back through that sort of line there. Yeah. And then perpendicular to that line is our, so the bearing's on 53. So if we were to 53, I wonder what we can do there. Let's just go to our little calculator, type in here negative 53 plus 180. Yeah, so that's 127, and so if we were to change that to 90, we're looking at 37. All right, so we're pretty good. Right, 37. 37 degrees is the bearing that we want our rows to run along if we were to have them perpendicular, right? 37. So there's a lot of numbers in that. Lots of numbers. Let's go 37. Where did I put my line? I put my line somewhere. Where did it go? Oh, it's down there, the face here. All right. So we will move those back to, let's see, what's this blast hole here? Position of 74.51. Okay. So let's move this to 74 and 51. Or I like that. Maybe 10. Not 10. Not very good at this, am I? Alright, that's good enough. We've got a line bearing there that we think is going to be good. I wonder if our move tool will help us with that. Let's we've got that selected. Let's get the move tool. Is it going to let us move the whole thing? Yep, certainly is. So here we have our line, and we can see that it sort of like grows through there. So it's not ideal, but let's put it somewhere here. Not ideal that we have that, because ideally we would want our line tool, but we don't want our holes to be we want our bearing to be perpendicular, so the drill can just put its mast on an angle and track out down the rows. Here I am talking, I've been on the camera all this time. Oh my god, what a silly idiot. Alright, so I should really have it bit more in my vision, but I don't want to be distracted by what I've done. Okay, so here we have this. What I'm quite concerned that I left that on. I wonder how long I've been talking with that on that thing. Anyway, we'll find out. What I was talking about was this line. I've drawn this line out. Initially, I drew this line across here, and we had it at negative 53. It was. And or negative, yeah, it was negative 53, and then I added, as I said, I added 90 degrees onto it, got to 37, because 90, and that was 180. So fast forward to this section, 127. What a nincompoop. So anyway, we've got that information, and we got our baseline for these blast holes, these next blast holes, and then we can put in a blast hole grid there, and let's make sure 102. Let's say we're at what's our spacing? 3.6, as we said, and 3 meters, and we've got let's say 12 holes and 5 rows for the moment. Just move this down here out the way. I feel quite silly that I've not been able to. So here we have our pattern, and we want to make sure that our pattern is aligned correctly. So first of all, I'm just going to get my pattern snapping to this, or aligned to this row. Alright, and now we're going to just move that pattern along. Should really get that on the money, just so that we know we're on the right orientation. Here we go, we're on the right orientation, and now we can move this pattern along and place it in our area. It needs more rows, doesn't it? So we need few more rows there. Going to put it like that, because we're going to delete what we don't need, and we want to make sure that we're in this line, on this line here. So that's pretty good. That's pretty good. These are all right. I think we're going to have, like I said, you're going to have to deal with this, and 0.5 meter, you're going to have to deal with this, and you're going to have to work it back to some consistency. Otherwise, you're always going to have faces breaking back. Anyway, that's essentially what we're doing here. So 15 holes per row. Yeah, that's pretty good. We're going to delete those extra holes out of that, and make sure. And we're pretty. I like this. This is lining up on the back run there. Maybe we need a bit further, a bit tighter. So that's what I've done. Move that up there, and then we need to move that up a touch and across a touch. And I'm sure there is, I'm going to do some more research. I'm sure there's some better ways to design blast holes and get them to snap to things. So let's create these holes. Now we could do it in a polyfill, which was to digitize an inside polygon, and then we wouldn't have to delete these holes that we know about. Let's do that. So if we do this polyline tool, and we know that there's going to be, we need a blast hole in here, on here. And at least I'm showing you the screen this time, not like before. Yeah, sorry about that. We'll just go back straight there. And so a lot of my preference for blast design is done line work. And personally, if I was in a more CAD-based program, I would consider that all the line work be done first. So if you're in CAD, you do all the line work first. So we're going to select that blast poly there, which is our last one that we did, and we're going to polyfill, and we've got the same parameters and same orientation, so we kind of like that. That's good because we had lined all that up, and now we're polyfilling it, and you can see here that it hasn't gone outside that, and the rows are sufficient. We've got a bit of angle there, so we could have, if we had increased it a little bit, would have got. We're just going to take this off, and that's the edge of our blast. It's relatively close to our blast master. Create. Okay, and close. All right, so that's relatively good. I'm just going to change these blast holes, and we're going to give them a, I don't know, let's go with yellow. So that's kind of it. These are all vertical, but we would be looking at putting these at 0.5 because obviously some of the distance between these toes are too big, and they may require a infill hole or something for an appropriate lot of management. We need to stick a hole in here as well, which we lost with our, should have paid attention to that, so we can fix that up another time. And we need to tack in a few infill holes because we need to hit a vertical hole at this point. So this one's 5 degrees, these are 5 degrees, so let's select these holes here. This has gone from second row to almost the whole blast design, but what I think I'll stop at this point. Yeah, it's an hour, and I completely apologize for not, I wonder how much of my live stream was just me talking on the screen, and if it is, then this will be deleted and I'll do it again and I'll pay more attention. But as you can see, we're looking at some pretty good toe stuff here, and we should look at what's our toe burden between this line here we'll do one more thing. I'll compress this down and compress these down. We'll get this toe position here. I think that's the right one, and we're going to offset this by the 3 meter, which is our full burden. And so you can see here that we need to just change that to red or something. Let's change it to red. Okay. You can see here this red line, and if you turn off these other ones. Right, there we go. This is where we need some energy at the toe. So we definitely need a hole in here, and we definitely need to think about what we do around this corner from this row back. However, we need a hole here. So these we need some holes along this line. We need some holes kind of here, and we need to manage that. Like, this is well overburdened, so this is probably not wise. You probably need something in there. But as you can see, with slow progression of angles, you need to do it very considered. And in this case here, like here, with progression through these angles, you need to slowly increase the angle, because as you can see, like we said, this is 4 meter separation, 4.2. So we would need to consider this next row at 5 degrees, and that way we can then compress this only a tiny bit. So that's at 3 meters, but this 3 meter collar now can come down to 2 meter collar separation. So you know, that might be 2. Yeah. So as you slowly stand up, now going from a high angled face to a vertical hole is very difficult in quarrying. So that's generally why people drill 10 degrees across the board or 5 degrees across the board, because they know what their face is going to break out at, and if it's religiously breaking out at 10 or 12, then they'll set their main body of the pattern. There will be their site specific parameters for that, and they'll set it at 10 and slowly progress back. I hope that this video is okay and I don't need to take it down. I thought I was alright at that. So like, share, subscribe. Obviously you can dislike this one if it was too much of my head and not enough of the information on the screen. Well, I appreciate every one of you for supporting and subscribing, and I hope that you enjoy it. I hope that I don't have to redo this one. But thanks for watching and helping someone out. Okay.